Okay, this is a video quiz for chapter 11, quiz 1, video review quiz. Let's look at this first question. We have negative 4 times radical 160. Now, radical 160 is radical 16 times radical 10. Now, what this is going to turn into is negative 4 times radical 16, or square root of 16 is 4. And square root of 10 does not break up. It's going to be square root of 10. Okay, why doesn't the square root of 10 break up? Because our perfect squares are 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, and so on. So we notice that 16 is on the list, so I'm going to break this up into 16 and 10 is not on the list. 10 is not on the list, so it won't break down. So now once I do the square root, I combine these two together, and I get negative 16 radical 10. Now I stop at that point because this is a whole number 16. It's not square root of 16. And the square root of 10 I can't break down. So this is my final answer. Looking at number 2. When you have a square root like this, try it on your calculator right away, and you'll get the square root of 144 equals 12. And if you think about the list, if you go to 10 squared is 100, 11 squared is 121, 12 squared is 144. So that is on the list, and 12 times 12 is 144. Moving on to the next one, number 3. It's a little bit more complicated. I have negative 3 times, well, let's bring, okay, square root of 180 times the square root of h to the 4th power. Well, we could try this one a little bit differently. The square root of 180, now if I don't use the list, I could go 2 times 90 is 180, and 9 times 10 is 90, and 3 times 3 is 9, and 2 times 5 is 10. Now this is all prime numbers. Okay, and I'm going to look for my doubles and repeats in this to see what goes out and what stays in. Now for every double, so I have a 2 and a 2, one number comes outside of the square root. So a 2 comes out, just 1 2. So I used up those 2. And then for double 3, 1 3 comes out. And then the 5, since it doesn't have a double, stays inside the square root. Now we can do the same thing for radical h to the 4th. Well, that's 4 h's multiplied together. And since there's a double here and a double here, that means 2 of the h's come out on the outside of the square root. Now when I combine all this together, I can do negative 3 times 2 is negative 6 times 3 is negative 18, and h times h is h squared, and then I leave the radical 5 underneath the square root sign. So if you could do this prime factorization way. If I were going to do the chart way, I would see that 36 goes into 180, and do it that way 5 times. Okay, it's a little bit, that's not as difficult, but let me show you that way, just so you have another version to see. So say you did it the chart way, say you did 180 the chart way, and I mean, even if you started with, well, I don't want to start with 4, because then I gotta, let me go with 30. I know 36 goes into it. Radical 36 times radical 5. This turns into 6 radical 5. Okay, but I got to combine that 6 and this 3 to get this answer here. Okay, and then of course I got to deal with the h to the 4th. Okay, moving on to number 4. Similar to what we just did, let's break it up. Okay, we could do this a little bit different. Negative 2, radical 2, radical p times 2 time, this is times, this is all times radical 22, but radical 22 is really 2 radical 2 radical 11. Now, you can see doubles here. Well, again, be careful. Whole numbers can be multiplied to equal -4. These two produce a 2 on the outside. Okay, so I've dealt with these things. I'm left with radical p and radical 11. They have to stay inside because they don't have partners. So this, I combine these two in front, -8, 11p. Okay, that's one way to do it. Now you might want to do this a different way. You might want to do this a different way. So let's try this one a different way. Okay, let's try this in a different way. So let's start with, let's multiply this times this. That's -4. And let's combine the radicals. So I'm going to have 2 times 22, which is 44p. 2 times 22, 2p times 22 is 44p. Now I can see that this produces a radical 4 and a radical 11, and the p is just radical p. And I can see how the 11 stays, and the 4 comes out front as a 2 and gets multiplied by the -4 to get your -8 here. So that's a little bit quicker, but you might not be able to see that way. Either way is acceptable. Moving on to the next one, number 5. Now this one, when there's fractions underneath the radical, those are bad. But can we reduce this fraction? First we got to say, can we reduce it? And the answer is no. I can't. 10 doesn't go into 81. Nothing goes into either number the same. So the next question is, are there any perfect squares underneath the radical? And there are. Radical 10 over radical 81. Well, radical 81 is a perfect square. We can leave the radical 10 on top, and the 81 turns into a 9, and we're done. That's our answer right there. Okay. Moving on to number 6. Similar to the last question, however, well, 9 doesn't go into 80, so be careful. It doesn't go into 80. It goes into 81, but not 80. So I can't cancel anything out. So let's deal with the top, and I'm going to separate it into square roots. Okay, the bottom clearly is a 3. Okay, however, we have 80 and w cubed. 80 can be broken down. Now, again, a couple different ways to do it. I would go with 16 and 5, right? Okay, that's one way to do it. Well, say you don't know that, say you can't figure that out. Well, let's just deal with let's do the tree method. So let's do the tree method with 80, because you're not sure about it. Well, 8 and 10, 2 and 5, 2 and 4, 2 and 2. If I go through and circle all my primes here, there's 2 2's and 2 2's there, so that's 2 2's on the outside. So on this thing over here, I can bring out 2 2's, which makes a 4. 2 times 2 is 4. So this produces a 2, this produces a 2, and a 4 comes out. The 5 stays in, and the 5 stays in. Square root of 5. Okay, we're not done yet. The w cubed is 3w's. We have one pair, so that puts a w on the outside. The other w does not have a pair, so it stays on the inside. So this final answer is going to be 4w radical 5w underneath the square root over 3. And that's my final answer there. Number 7. I don't see perfect squares there. 400 looks like a perfect square, but before we do that, well, 400 is a perfect square, but before we do that, let's go 5 into 400. Well, let's try it 2 different ways. 5 into 400 is going to be um, radical 80, right? 8 times 5 is 40, with the 0 is 400. Radical 80. And we just did radical 80. We broke that up into 16 times 5, right? 50 plus 30, yep, which is 4 radical 5. So this answer here is 4 radical 5. Well, say you didn't know how to do it that way, and say you did the other method. Okay, the other method would be this way. You would do radical 400 over radical 5. Radical 400 is 20 over radical 5. Now you're not done yet. Okay? What has to happen here is you got to rationalize this denominator. So multiply the top and bottom by radical 5. I wouldn't suggest doing this way. If you could, do it the first way. But if you have to do it this way, we'll try it. So I get 20 radical 5 over 5, and then you have to know enough to reduce the 20 and the 5, because 20 is really 4 times 5, so these 5's cancel. I'm left with 4 radical 5. Okay, you can always test this on your calculator, so this would be a good time to test the calculator. So how do I know my answer is right? Well, turn your calculator on, and enter what they have there. So it's the square root of 400 divided by 5 in parentheses, and that comes out to be 8.9. And then do your answer, 4 times the square root of 5, and you'll see you get the same answer. So that's going to check for you, so you know your answer is right. Moving on to number 8. Okay, looks a little scary. It's very scary. Well, let's reduce the fraction first. Well, first of all, 63 and 7 are compatible. The x's are compatible. And the y's are compatible. This is going to be a little bit of an ugly question, but let's see what we can do with it. This first one turns into okay, interruption. Okay, so this is going to turn into radical 63 divided by 7 is 9. Okay, this is going to turn into radical x to the 15th divided by x. There's 15 x's on top and 1 on the bottom. That's going to reduce to x to the 14th. And here we're going to have radical 9 over 11, which is going to reduce to 1 over y squared. Okay, now be careful with this. This here is going to turn into 3. This turns into x to the 7th, because there's 14 of them, there's 7 pairs. Here, you're going to have 1 over y, because you got 2 pairs of y on the bottom, so it puts 1 out front. So your answer is going to be 3x to the 7th over y. So this wasn't actually too bad of a question. So you want to reduce first. I mean, you could reduce here. 7 goes into 63 9 times. 1x goes into 15x's 14 times. And 11y's goes into 9y's 2 times. And you're taking the square root, so now you're going to take the square root of the top, which is 3x to the 7th, and the square root of the bottom, which is just y. So that's a quick question. Number 9. 21 is not a perfect square, and 4 is not underneath the square root sign. So be careful with this. Don't take the square root. You want to multiply the top and bottom by radical 21. You have to rationalize this. This breaks the third rule. Okay, this turns into 4 radical 21 over 21, because the radical times itself is what's underneath the radical sign. And that's as far as you can take this question. This question is actually easier than you think. So let's check that. So when you do this tomorrow, if you do this tomorrow, check your work on it. Check your work. So 4 divided by the square root of 21 is 0.87287. And then let's try 4. Okay, we were checking this question. 4 second radical 21, in the parentheses, enter, and then divide that by 21, and you'll see you get the same answer, so it does check. Number 10, let's, well, quickly do this. Again, 7, this is times the radical of 100 over 500. Well, that turns into, this one's a little tricky. This turns into 7 over, or 7 radical 1/5, which equals 7 over radical 5. So this one's a little tricky with the notation on it. I guess the best way to go is to do 7 on top. You could say 7 over 1 radical 100 over 500, and that's going to turn into 7 over 1 times, that's probably no good way to write this. 7 radical. Either way, you got to rationalize 7 over radical 5. You multiply the top and bottom by radical 5. That turns into 7 square roots of 5 over 5, and that's as far as you can go. So reduce this. Reduce the 1s. The square root of 1 is 1. That turns into 7 over radical 5, and then do your rationalize your denominator. Number 11, 1 of these plus 2 of these is 3 of these. Done. Number 12, these do not match, but 63 is really radical 9 times radical 7, which turns into 3 radical 7, but remember the 8, so that's 3 times 8, which is 24 radical 7, and then you got to add 4 radical 7 to that, and 4 plus 2 is 6 radical 7, and it checks out. Okay, I'm going to stop the video here. Hopefully this is enough to get you a good grade on the test. God bless you. Amen.